this video, we are going to talk about the remainder theorem. So, according to the remainder theorem, if a polynomial p quantity x is divided by x minus c, where c is a real number, therefore the remainder is p quantity c. Diba, when we divide polynomials, for us to be able to find the value of the remainder, which is your r quantity x, we can either use division algorithm or synthetic division. But then, according sa remainder theorem, we can identify the remainder if we evaluate p quantity x using the value of c, which is your divisor. Okay? So let's see if the remainder theorem makes sense by solving the remainder of this given polynomials. First, we will use synthetic division. Okay? So we are going to test this theorem if it makes sense. So una, gagamitin natin synthetic division para malaman natin kung ano yung remainder nitong given natin. So let's say we have 5x squared plus 3x minus 2, and we will divide this polynomial by x plus 1. So using synthetic division, diba, we will write the coefficients of the dividend, okay, or the p quantity x. So solving this, okay, using synthetic division, this will be written as 5, 3, and negative 2. So we have no problem kasi meron tayong constant, first degree, and then second degree. And they are arranged in descending order kasi yun yung rule sa synthetic division. And then we will be finding the value of x by equating the divisor. So this will be x plus 1 equals 0, and then x is equal to negative 1. So negative 1, we are going to put that here. Negative 1. And then the plus sign here. Okay? And then I'm going to put the line here. Okay? So, sa synthetic division, always nating binibring down yung first coefficient. Okay? So, bring down 5, and then we need to multiply 5 by negative 1. And then 5 times negative 1, the answer is negative 5. And then 3 plus negative 5, the answer is negative 2. And then the process will be repeated. Negative 2 times negative 1, the answer is 2. Negative 2 plus 2, the answer is 0. So if we will be writing the answer here, we are going to arrange this in this coefficients or these numbers in this form. So this will be a remainder, and then the constant, the first degree, and then the second degree. So kapag kinuha natin yung answer, i-arrange natin yung numbers na to. So yung number na nasa dulo, that will be your remainder. So 0, your constant is negative 2. The first degree or the coefficient of x is 5. So kapag sinulat natin yung answer nito, we will come up with I'm just going to move this now. We will come up with this answer. So our q quantity x is 5x minus 2. Okay, 5 is the coefficient of x, and then your constant is negative 2. So your quotient is 5x minus 2, and then the remainder is 0. So using synthetic division, we now know that the remainder of this given is 0. Okay? Using synthetic division. But then, sabi ni remainder theorem, we can compute for the remainder without using either division algorithm or synthetic division. Paano? Let's evaluate the p quantity x or the polynomial or the dividend. Okay? So what will happen, I'm just going to erase this, no? We will be evaluating the polynomial given or the dividend given using the value of the constant. So, ma'am, ano yung constant? Diba, sabi dyan sa module nyo, we will be looking for the value of C. Okay? So, for us to be able to find the value of C, si x minus C, siya ang divisor. So, we will be equating the divisor. Okay? We will equate it to 0 for us to find the value of C, which is your constant. So, x plus 1 equals 0. Equate natin sa 0. And then, transpose natin C1 to the right side. And this will be now the value of your C, which is negative 1. So, x is negative 1. In short, parang sa synthetic division lang din siya. Kukunin natin yung value ng x. Okay? And then, what will happen next po? We will be substituting the value of x to the x's here in the polynomial given. Ganun tayong mag-evaluate, diba? I already discussed how to evaluate polynomials and we will apply that here. So, we have p quantity x ang given natin is 5x squared plus 3x minus 2. So, using the value of c, which is negative 1, okay, yan yung c mo eh. We will be substituting negative 1 to all the x's here in the given polynomial. That is how you evaluate polynomials, diba? Using substitution method. So, p quantity negative 1 equals 5. Quantity negative 1 negative 1 squared, okay, plus 3 quantity negative 1 minus 2. And then, we need to get rid first of the terms na mayroong exponent. So, we have p quantity negative 1 and then 5. Negative 1 squared, the answer is 1. Okay? Plus 3 times negative 1, the answer is negative 3. So, maglagay po ng parenthesis for you to be able to separate the operational sign to the sign of the number. Okay? So, minus 2. And then, we need to get rid of the parentheses. So, we have 5 times 1. Okay, so that is 5. And then here, we can multiply the signs. So, positive times negative 3, the answer is negative 3. And then, we have minus 2. And then, continuously compute for the answer here. So, dire-diretso natin solve it. 5 minus 3, that is 2. 2 minus 2, that is 0. So, therefore, same ba ng nakuhang remainder kanina using synthetic division? So, kanina, sa synthetic division, we did get the remainder of this given as 0. Dito, 0 ba yung nakuhang remainder? Yes. So, therefore, the remainder theorem makes sense. You can actually solve for the remainder without using either division algorithm or synthetic division. But then, you can just evaluate the polynomial using the value of your C. Okay? So, yun lang yung ibig sabihin nun. So, ang mangyayari sa remainder theorem, imbes na gamitin niyo yung division algorithm or synthetic division to find the remainder, you can just use remainder theorem in finding the remainder. So, halimbawa, remainder lang naman yung pinapakuha ko. You can just evaluate the polynomial given. So, let's have more examples. So, let's say I am going to told you to find the remainder lang, okay, or quantity x lang of this given polynomials. So, imbis na you're going to use division algorithm or synthetic division, you can just use remainder theorem in finding the remainder of the given polynomials. So, we need to find the value of C, so we need to equate this divisor by 0. Okay? So, x minus 1 equals 0. X is equal to transpose negative 1 to the right side. So, the value of your C is 1. Okay? And then we have p quantity x and then the given polynomial here 3x cubed minus 7x plus 12. And we need to substitute c or the value of x kung saan kayo masaya. Okay? to all the x's here in the given polynomial. So we have p quantity 1 equals 3 times quantity 1 cube minus 7 times quantity 1 plus 12. So p quantity 1 equals 3 times 1 cube is simply 1 minus 7 times 1, that is 7 plus 12. Okay, p quantity 1, we need to get rid of all the parentheses. Okay, so 3 times 1, that is 3 minus 7 plus 12. And then right after that, we need to compute this continuously. So 3 minus 3 minus 7, the answer is a negative 4. So negative 4 plus 12, the answer is 8. Excuse me, 8. So therefore, the remainder of this given is 8. Without solving the quotient, you know the remainder. That is because of the remainder theorem. Okay, so let's solve more examples. Let's say we have example number 3, and let's say I am going to make you find the remainder of x squared minus 7x plus 10 divided by x plus 2. So first that you need to do is to find the value of c, or to find the value of x here. Now you need to substitute in the polynomial. So for you to find that, you need to equate the divisor by 0. Okay, so x plus 2 equals 0. You need to transpose positive 2 to the right side, so it will become negative. So that is now the value of your c, okay, or the value of your x, negative 2. And then rewrite the given just like this, okay? So, yeah. And then the value of your x, or the value of your c, you need to substitute that to all the x's here in the given. So we have p quantity negative 2 equals negative 2 squared minus 7 times quantity negative 2 plus 10. Okay, and then p quantity negative 2 equals negative 2 squared. The answer here is 4. Okay, minus 7 times negative 2. The answer is negative 14. I am using parentheses to separate the operational symbol to the sign. Okay, so don't be confused with the parentheses always. So plus 10. So p quantity negative 2 is equal to 4. So we need to multiply the sign. So negative times negative 14. The answer is positive 14 plus 10. So now continuously compute for the answer here. So we have 4 plus 14, that is 18, plus 10, the answer is 28. Therefore, without computing for the quotient, you now know the remainder of given number 3, which will result to 28. So, ma'am, yan yung remainder, no? Example number 3, without computing for the quotient or anything else. Okay, so let's solve the last example. Let's say we will find the remainder of this given polynomial. So we have 7x squared minus 3x plus 5 divided by x plus 1. Okay, so again, you need to equate this first, the divisor, for you to find the value of the c. So x plus 1 equals 0, x is equal to negative 1. And then rewrite the given like this. P quantity x is equal to 7x squared minus 3x plus 5. And then using the value of the c or your x, okay, substitute it to all the x's here in the polynomial. So we have p quantity negative 1 equals 7 quantity negative 1 squared minus 3 quantity negative 1 plus 5. And then get rid of the exponent and the parentheses. So P quantity, negative 1 equals 7. Negative 1 squared is simply 1. Okay? Minus 3 times negative 1, the answer is negative 3 plus 5. Don't be confused again by the parentheses. I am just putting parentheses to separate the operational sign to the sign of the number. Okay, so P quantity negative 1 equals 7 times 1, the answer is 7. And then we can multiply the sign. So negative times negative 3. Okay, the answer is positive 3. And then we have plus 5. And then continuously compute for the answer here. 7 plus 3, the answer is 10. Plus 5, the answer is 15. Therefore, without computing for the quotient, you know the remainder of number 4 or example number 4 is 15. So that is how the remainder theorem works. Without computing for the quotient, or without using synthetic division or division algorithm, you can compute the remainder of the given polynomial using remainder theorem.